that just came on, and it's difficult because I don't want to say I got in trouble, but I was trying to take attendance for in-person and remote. I felt like I was doing cartwheels all day, Thursday and Friday, trying to do the right thing. And then they were like, no, don't do in person. So
you have to.
It's gonna echo.
No, that's a good thing.
no, I mean, unless I ask you to unmute yourself. Did Mr. Cobb already do his morning announcement thing? He didn't do that?
No, he did.
Okay.
All right, I'm done with this
Suicide's
bullshit.
bad. Badass.
Kaden, stop it. Okay, so Alexis, Braylon, Kale, I think I got Kale. Kelsey, Dylan. That said, go ahead and do the opener, and I'll talk about it in a second. This is not fun trying to take attendance from home. Dylan, why is your thing upside down? Dylan. Alexis.
What do we do? The week's not up.
It's pinned. You have to, okay, so in order to, the link is not up. It should be pinned, not my face slide, the presentation slide. That's the one that you guys should pin to your screen. Hold on.
She hasn't posted anything. How the hell am I supposed to do it?
For real.
Oh, wait. I have to activate the module. Hold on. I'm activating the module. That's what I forgot to do. I apologize. I just went back and double checked everything, and I forgot to actually activate the module. It's my fault. Let me turn off the other ones. No, I have. I've posted the entire week. I just unposted a whole bunch of stuff. I just forgot to make the. It's always going to be something, isn't it?
Yeah.
I apologize. Okay, and then to see what we're doing, are more than one of you. If I've got more than one person whose mic is hot, it's going to do that. I see Decker. I see Erica.
I'm here. What's up?
I'm just taking attendance.
Dude, what are you doing that? I need a cup.
I mean, really, I can't have more than one mic that is active in person. If you're remote, you could stay active because we won't get that echo. It's the students that are in the classroom that cause that really bad reverb. But yeah, I apologize. I forgot to actually publish the module. I made everything else active. Okay, I don't see. Is Otis in the room?
Yeah.
Yes. Okay.
Wait, so are we doing the Google Meet or something else? Okay, good talk. Oh, she lived.
Okay, so for the opener today, if I go back to the correct screen, like I said, sorry, I didn't publish it. It's published now. Go back in time before electricity, before cell phones, before radio, before all that.
What am I
And why
doing?
do we have such a bad echo? Do I have more than one open? I don't think so. How would you know, just by digging in the dirt, if something was younger or older? What's the only way that you would be able to tell that if you didn't have modern technology? And then your notes are in Canvas. I know that there is a way to split your screen so that you could have the notes on one side and then like your notes on one side and then my screen on the other side. Worst comes to worst, I'm recording. So I will post it immediately into Canvas once, I should be able to do it during second period. But another thing that I did, and I'm not going to share my screen yet. Another thing I did in Canvas was I reposted a link that I did in the first 6 weeks, how to submit your notes digitally. If you've been doing paper notes, that was something that I gave you a chance to do Friday, was to start taking pictures or converting or scanning, however you can get it into Canvas. And then you really need to put everything into a second 6 weeks folder. What I forgot to mention was when you go to get that link, the thing that looks almost like a paperclip, you need to switch it from restricted to ASL. Because if you don't do that, I can't see it. And I have to ask for access. So I reposted in Canvas, now that the module is actually hot. The last thing for today says 10/26/29 notes turn in link. If your notebook is ready, I am not looking for today's notes. And if we do notes tomorrow, which I've built them, I don't know if we're going to do notes tomorrow or not. I've got to figure that part out, but they're built. Your notes, let's see here. Did I put it? Could have sworn I had, look. Somewhere I have a copy of the titles of the notes, and I'm not seeing it this second. Hold on, let me find it. Open ESS, second 6 weeks, resources. Here we go, this guy. Okay, I am in the process. I thought I had put this in Canvas, but apparently I did not. I am in the process of, I'm going to put this. Okay, so where the notes turn in link is, I am going to, in the information, sorry, I'm doing it literally as I'm talking right now, putting a copy of the list of the notes that we did. It's in the order that we took them just for the 6 weeks. So I am starting up the next unit right now, and I'm getting ready to double check, make sure everything's in. Cassie Joseph. Okay, I'm gonna double check in just a second. So if you see, there's two different things you can see. You can see me, and then you can also see my presentation. That's the one that should be up. If you can split screen with your notes, awesome. I'm so sorry once again for those of you that are used to doing paper notes that this is the way it has to be for at least this week. So let me get started. We are going to be talking about how we've measured the past today. As an overview. Tomorrow, if we go into it, we will go into depth with relative dating. Friday, I'm going to have to make sure that all of your stuff is taken care of. So that's going to be, we may or may not do those notes tomorrow. I'm not 100% sure. Wednesday is odd 6 weeks exams. And then Thursday is even. I don't think I have that backwards. Friday is sort of like a, did you miss your test? Is everything turned in day? And then we'll continue on with all this, the history of the, we're not quite at dinosaurs yet. Don't get excited. Dinosaurs are, even though we're going to talk about some of these epics and eras, we're not going to actually get into dinosaurs until the 4th 6 weeks. So we are going to talk about just how we know geological time, and we're going to do with what we know for sure, and then we're going to go back and do the history of it, which these people did not know any better. They were figuring this stuff out in the 15 and the 1600s. They didn't have all the cool things that we have now to be able to date these meteorites. So from the first 6 weeks, we know that our solar system is just over 4.6 billion years old. We've dated the Earth to be 4.57 billion years old. We've done that with testing heavy metal radioisotopes in asteroids and, well, not really asteroids, but the meteorites that have actually made it to Earth's surface, because to our knowledge, those asteroids and those meteoroids, before they hit Earth, they all formed at approximately the same time that the Earth did. And they date to just under 4.6 billion years ago. So this was something that we have already talked about. This is sort of a, yeah, we know this, and then we're going to go back in time and we're going to explain. Dude, sorry, my cat. Go. Rush, go. Oh, yeah, this is going to be fun. I'm so sorry, but he's stuck in this room with me. Lay down. Lay down. Lay down. He's not listening to me. Okay, so you guys have this in Canvas. It starts way down here at the bottom in this curly Q, about 4.6 billion years ago. The oldest rocks that we can actually date are about 4 billion years ago. Remember, the Earth was sort of this molten mass for the beginning part of its life, and it was constantly being bombarded with asteroids and comets, which brought us our water. And then over enough time, once we had that global chemical differential that happened right around here, we had our first crust, which is why we don't have rocks before that particular time. We didn't have a rocky surface. It was literally a molten ball of iron plus all those other elements. And then we had all that volcanic outgassing and that bacteria. So we're coming around this little loop to about 3 billion years ago. These were the first cells that we actually have recorded. And this is not the only planet that we have fossilized cells. We've seen that on Mars. We've actually found it on asteroids. So we'll come back and we'll end up going up through here. We don't really have life that we even think of it that's not bacterial until we hit the Cambrian period. But we're not going to go all the way through all these little guys until we do the history of life, which is in the 4-6 weeks. But I went ahead and gave you this image on Canvas. I actually have this a couple different ways. And when we're talking about time on the planet, there's two different ways that we measure time. One is what we call relative age dating. There are no years here. There are no time frames here. It's just which happened first and then what happened after. And that was part of the opener, was if you're digging down, the further down you dig in general, and there are some exceptions, but in general, the further back in time you're going, because dirt gets set down. It takes about 100 years to make an inch of dirt, but dirt gets set down on top of older things. And the relative age version of this just lets us know if something is older because it's deeper, or is it younger because it's further towards the surface. But like I said, there are no actual years with relative age dating. I see a kitty cat. I don't know if you can hear him purring through the computer. I'm sorry if you can, but he's one of those cats. It's just a sequential order with relative age dating. I'm going to try not to go too fast. I can't, unless you guys unmute yourself and say I'm going too quickly. I don't know. I will post this, though. Excuse me. Now, you also should have this guy in Canvas. If you notice, there are no years. In fact, I use this image a lot. But the further down you go, just like digging back in time, the further down you go, the older we are. The closer to the surface, the more towards now. And we're up here. We're way, way, way up here. But we have eons. There are 2 eons. The Precambrian is technically both an eon and an era at the same time. It's basically life that was just bacteria. But it technically follows or falls under both an eon and an era. But eons are your largest periods of time. You have your from birth, essentially, to about 2.5 billion years ago, that was just bacterial. And then we started having life in the seas, and then eventually we had plants on the land, and we had dinosaurs, and eventually people. That's up here in this particular eon. Going smaller, you have eras. there are 3 eras that end up going underneath the Precambrian. Like I said, this is all bacterial down here at the bottom. You really don't need to be laying on my hand. Getting younger, we've got periods, and then the only one that actually has epochs are in the Cenozoic, which is where we belong. But once again, there's no hard year, month, day. We really can't. With half-lives, which we will learn how to do half-lives probably next week. I don't see that happening this week. You can date knowing the half-life of a radioisotope, how much time has passed. It's just how dead is the thing, how long ago did it live, is going to control what type of radioisotope that you're going to be forced to use. But once again, with the relative time, it's just older in general is deeper in the earth. And then you have layers. It sounds like I had somebody ding on. You have layers that are going newer in time or younger in time. Let's see, I have somebody new. Doesn't look like it. It may have been an email. Yeah, it was an email. Okay. So eons, your 2 largest groupings, the bacterial is Precambrian. Like I said, that the Precambrian sort of is both an eon and an era at the same time. And then everything that's after bacteria, anything that has essentially more than one cell. It sounds like there's something in the chat. Everyone is being loud. I did put some more Learning Lab. I cut some more up and put them in that blue binder, which was on my demonstration table. I don't know if it's there or if it's if it's on my desk, but I think I have the cutoff for that 4 o'clock today. And I sent out an email also with the, okay, I need you to shut it because I'm teaching. The email that I sent you has the access code to it too, but I sent that out Saturday.
I haven't been on my, I haven't really been on anything this weekend because of the play. So
Okay, but go back and look at your Gmail because I sent one out.
I just saw my Gmail. I was actually about to email you, and I just saw that email.
Okay, I have no problem if you go to the Learning Lab. I will post this and put it up on my account as soon as I'm able to.
Okay, thank you.
Okay, so eons, they're the 2 biggest groups. Eras are going to be your subdivisions. Like I said, Precambrian technically counts twice, technically. But then we have going past that, the Paleozoic, then the one that has the dinosaurs, the Mesozoic, and then the one that we're in, the Age of Mammals, which is periods are a little bit smaller than that. They're subdivisions of eras. And then epochs, the only one that has epochs is ours, the Cenozoic. Let me double check and see who's missing that test also in this class. In this class, that test, and you have, especially if you were here, you have through 3:59 technically to make up that test. Otis, you did not take your test. Caitlin, if you're online, you did not. Just talk to Erica. Courtney, if you're online, you did not. Mauricio, if you're online, you did not. I sent you a Gmail, if I am not mistaken, Saturday, telling you how to take this test. It had the access code in there. It also explained the missing picture. Picture number 9 is a reverse of picture number 10. I did include that information. I went back and edited the question. I don't know why Canvas didn't like that image. There's nothing wrong with it. It's just a front.
Good morning, Miss Richie.
Good morning. Erica said y'all are being bad.
Is it echoing?
No, she said y'all were being bad and being noisy and not paying attention.
Who?
The student that just left.
What student?
Oh, goodness.
Erica?
All right, make it back.
Well,
Let's
she's
see.
not talking about us because
Mm-hmm.
she's talking about this annoying kid in here.
Oh, okay. That
I don't know. I just joined because I thought you were gonna count me absent or something because it kicked me out.
I think I got you. Like I said, I'm not really. Yeah, I got you. I'm only supposed to be doing remote attendance. I thought I was supposed to be doing both, and then Miss Moore like said, "No, don't do that." So,
So, I guess.
the substitute I think is supposed to do in person.
But-
All right, let me go on. You guys
But yeah, I
should.
mean, don't listen to Erica. Don't listen to Erica because you know how she is. We're not even. Me and Decker, we're not even talking. This is what's your name?
Nathan.
Nathan is the one that's talking.
It's not Nathan. It's
Mhm.
Nate. So that's who she is.
Johan, don't eat in my room.
Huh?
I can see you. Don't eat in my room.
My stomach hurts if I don't eat breakfast, man.
Oh my
So I'm sorry, I'll
lord.
put it away.
Okay. I'm going to mute you and I'm going to go forward because we're going to run out of time. Okay. So,
Can I ask a
Oh.
question? Is this, are you gonna like post these notes on Canvas because I missed
I am.
the point?
yeah, I am.
Alright, good.
I'm recording it right now. I'm going to post them as soon as I have the ability to.
All right, thank you.
Mm-hmm. Okay, so this is the same thing. It's just a different version, and I'm not sure if I gave this one to you. Let me look. Looks like I did not. I just gave you that first one that we did. The Precambrian was your bacterial life, and it is split into a couple of smaller groups. But we started off with the Archaebacteria. The Hadean was the beginning, essentially, of life, the end of the Hadean period. And then you had your what we call Archaebacteria, so that's why that's called the Archean. And then you had the next ones that started photosynthesis, the cyanobacteria fall there. And that literally was the first 4 billion years of the life on this planet. After that, the Phanerozoic, this is when we had what you would consider animals. Okay, not like people, but your like things like shelled things, clams in the ocean at this point, but things that had a hard shell. That was the beginning of the Cambrian. So those were the two big splits. It's basically all bacteria down here, and it's things that are more than bacteria up here. So this particular eon is everything that is more advanced than just bacteria. All right, now the other type of dating. So relative is just this came before that. That's it. Absolute, we couldn't do until we could use radioisotopes, and we didn't understand radioactivity until the end of the 1800s. We have now it's not pinpoint to the second, but we have a way to measure time when we deal with things called half-lives. Now, if it's like an Egyptian mummy and it hasn't been dead for a super long time, which I know is still a long time for us, but in relationship to the earth, it's not been dead for a long time. If it's something like that, that still has tissue, not like what you think of as your skin, but you could drill into the teeth and you could actually get DNA out of it, we can use carbon-14. And the half-life is almost 6,000 years, just the half-life of carbon-14. It's a little less than that. If it's something that's like dinosaurs or rocks towards the beginning of the life of this planet, we're going to be using heavy elements, things like uranium, because there's not enough carbon-14 left. Like, it's gone. So we can't measure with that particular radioisotope. So carbon-14 is really only for things that have been dead for, let's see. So if I do 6, 12, 24, 48, definitely less than 100,000 years dead. I have to go back and look up the actual formula for calculating it. But with carbon-14, just under every 6,000 years, only half of the original amount is left. So this same thing that you guys have, it was the discovery of radioactivity. The Curies were one of the first ones to really deal with this. And yeah, they got radioactive poisoning and they died from it, but we didn't know any better. So the end of the 1800s, we started using these radio isotopes to be able to figure out a true time frame. But so our time scale that we're looking at over here is actually a combination of the two. And until we actually had fossils, we couldn't really put any kind of a numerical value in any of this. And even then, using fossils and radioactive isotopes, it's sort of like a ballpark figure on how long ago that happened. It's not perfect. Like I said, it's not down to a second. You know what I need to do is to go into relay. Give me a second. Let me open that. My computer's slow. Well, it's just spinning. Okay, well, my computer's trying to figure out what it's doing. I'll move on. I don't know if it's the rain or what. So now changes that we've had. Now we're going to be going back into history because the stuff that we talked about, we've known the whole 4.57 billion years ago. We've known that because we have technology, but that hasn't always been that way. So if we go back, now we're going way back. This is like Isaac Newton, like Black Plague kind of time frame. So back in the late 1500s to mid 1600s, he used the book of Genesis in the Bible, and he decided that today essentially was Earth's birthday, literally October 26th, 4004 BC at 9 a.m., bam, the Earth was created, according to the research that he did with the book of Genesis. So I can't really go into theology. I don't want to get into trouble, but he took the writings of the Bible and compared it to the things that we do know, the buildings and structures that we do know. And he said that everything was created at 4004 BC at 9 o'clock in the morning. Here we go. My canvas just worked. I forgot to open my. Okay, so back then, and I'm not saying anything against the church, I'm not, but back then you did what the church said. This man ended up going on to becoming a priest later on in his life, or maybe it was a bishop. But not long after he said this particular information, if you went against that, you went against the church, and it was heresy. They like to burn people at the stake. They like to draw and quarter. They like to do all different kinds of things to people that went against the church. So, like I said, I'm not against the church. I'm not saying that at all. It's just that is what happened back in the 1600s. I'm getting texts from coworkers. Rushy, get your head off the computer. If my cat types, I'm sorry, because his head is on the computer. All right, so this is an image of Mr. Usher. They all wore these fancy Victorian collars to hide all the scabs that were on their neck from the insects that lived in their clothes and in their hair. And it was in fact, it was considered unhealthy to not be covered in lice and fleas. And that was a sign of health back then. So they wore all these fancy collars to hide all the scabs on their neck, which is disgusting, but that's what they did. So in the 17 and 1800s, we had our first scientific measurement. My fellow coworkers are blowing on my phone. Okay, somebody apparently has a substitute and they didn't set up for a sub. So in France, what he did was he took iron, which we know that the core of our planet is 35% iron, and he used molten masses of iron of different radii or diameters, and how long it took them to cool off, and then knowing how large the planet was, figured out by comparison that the Earth was 75,000 years old. Now we know this is nowhere near right. Okay, so but we went from about 6,000 years old to 75,000 years old by the first scientific type experiment trying to figure out how old this planet was. Let's see if that's working now. Oh, it is not working. Let's try reloading it. There we go. Continue. Nathan, pay attention. I am going to screenshot and send it to your father. Don't forget, I have the ability to see your screens. So this is an image of this Frenchman. We're just a little bit further in time. We're about a little over 100 years after the previous one. This particular individual, James Hutton, the father of modern geology, this was the first guy that really figured out that we could take a look at ancient rocks to figure out how old our planet was. I can't remember. I don't think there's another one on here. There's not. Okay. Now we've found older rocks than he found in the 1700s. They're called stromatolites. In fact, stromatolites aren't even rocks. It's fossilized bacteria, which is why we know that we had bacterial life to a certain point ago, is we have the fossilized evidence. Now it wasn't anywhere near the amount that we know now that they knew back then, but they were starting to truly scientifically try to analyze how old the Earth was. Starting with the previous guy with the molten balls of iron, with how long that those took to cool, and then compared that to the radius of the Earth, that how long that would have taken to cool. Now, they didn't know anything about bacterial life with that previous guy. And with this one, I don't think the stromatolites were identified yet. Like I said, that's actually pushed into the 4-6 weeks when we talk about the history of the evolution of life on this planet. We sort of talk about it now because we have to, but we don't go into depth. All right, next individual, Charles Lyell. We're getting quite a bit more modern now. And we will talk more about uniformitarianism. If we do it tomorrow, I'm still trying to figure out exactly what we're doing tomorrow. Once I get through with this, I'm going to share my screen so that you guys know for your notebooks what we're doing. But he went against the church. He wasn't killed. And this was the time when everything was really being challenged against the church. And it switched it from that much more of a biblical kind of theory, which was from Ussher, to much more of a scientific model, which, like I said, and we've talked about this before, this was dangerous back then. It was very, very dangerous back then, because if you went against the church, they like to do bad things to people. Not quite so much at this point, more in the 1600s. So we had other people, and I'm not going to talk about every single person, but we had other people that used what's called deposition. It means the depositing of sediments and how thick those are as you dig down into the earth. And if you've ever been on if you've been river rafting or anywhere where you can see canyon walls, or maybe they dig through the rock to be able to put a road, and you can see the different layers, they're different colors in the rock. That's called deposition. And once we started figuring that out, then we said, well, the earth is at least 1 million years old, but it could be at least 2 billion years old. And we were getting quite a bit closer because, once again, we didn't have the ability to do radioactive isotope dating at this point. Jolie took a look at how much salt, the salinity of the ocean, and that's actually brought out by the rivers. And he just mathematically figured out that the earth was at least 90 million years old. So these two actually happened at about the same time. And we're not even in the 20th century yet. We're almost. What, Kitty? Get your nails out of my arm. Let's see here, and then we need to do. We have the 4 relative principles and then the absolute dating principles. And we will come back and do relative in depth possibly tomorrow. We will see. This is going to be a fun week this week with 6 weeks assessments. All right, so relative dating, we have 4 main parts. We have what is called superposition, which means that the oldest things settle, then you have something else settle on top of it, which is younger, something else that settle on top of it, which is younger. Original horizontality just means that specifically if it's in the ocean, if it's marine, that the layers are perfectly side by side. That's horizon. It's horizontal. So superposition just means that the oldest things are at the bottom. Horizontality just means that hopefully nothing weird happens and they're all these perfect, almost like pancakes on top of each other as you go younger in time. Lateral continuity means that if we've had a disturbance like an earthquake, if we've had a fold, or if we've had a dip, that if you do go, let's say you go whitewater rafting, when you look up, you see certain layers that are the same color, and then above that might be a redder one, and then above that might be a paler one, that you can see that those sections that you're going through, they match, and that's lateral continuity. Cross-cutting happens when we have lava shunts and you have very hot magma that's coming up through the rock, and it creates what's called a fault, a shunt, or a dike, D-I-K-E. Those particular things are always darker than the rocks that they cut through, and they're also always younger. And we'll get into that stuff. Like I said, if we don't do it tomorrow, we'll probably start off with the relative dating in depth on Monday. Absolute dating, this is the modern version. You have to have some type of a radioisotope, carbon-14, if you're trying to date something that still has. Okay, sorry, I've got fellow teachers that are blowing up my phone. But we did not understand this until the very late 1800s. And this will let us know, if you know your half-life, how much is remaining is how many half-lives have occurred. You apply that to the actual half-life in years, and that gives you a true year value. Okay, so I'm going to switch. I'm going to stop the recording right now, actually.